Welcome to the second episode of Parent University. In this episode of Parent University, we're going to learn the basic building blocks of the universe and how they relate to electricity, how atoms operate and what they are. We're also going to learn about why we might get shocked when we touch a doorknob and how that is different than the circuits we've learned to make.
So I've seen coding, I've seen robots, I've seen all this stuff. But to go up to a student who's never seen electrical engineering or any science, technology stuff at all, and then just hold up a battery and an LED just light up, it's like entering into a whole new world, like new universe of like magical ponies, unicorns, and all that just opened up to them. My name is Mark. I am a mechanical engineer who works for RoboFun. So an atom is the smallest building block in our universe, right? Everything is made up of atoms, right? Whether it's a desk, fish, water, our atoms are made up of three parts, right? The protons, neutrons, and electrons. Okay. Electricity is coming from electrons. Protons and neutrons make up what element an atom is going to turn into.
Protons and electrons have roughly the same amount of charge, even though protons are positive and electrons are negative. So a proton and an electron will actually balance each other out. Protons and electrons tend to attract one another. The negative charge of the electrons like going towards the positive charge of the protons. Atoms tend to like having a neutral charge with the same number of protons and electrons. In a second, Mark's going to tell us why sometimes atoms don't have the same number of protons and electrons.
So the Bohr model was a diagram created to visualize how an atom would act, behave, and look like. While it's not 100% accurate, it is the best known model for atoms. So what the Bohr model does is it sets up the nucleus, which is made up of protons and neutrons in the very center. And then it places rings around that nucleus to display the paths electrons would take. And then on each ring, there's a certain amount of electrons that can exist, no more, no less. The further away an electron is, or the further away a shell is, right? The shell is the path that these electrons take. The more energy an electron has for itself to do whatever it can, whatever it wants. It has more freedom. If the electron is on a shell closer to the nucleus, it's much more confined. You would require significantly much more energy to break it away from the atom. One electron in the outermost shell is the free electron. And that's the electron that we all think and know of when we think of static electricity, current electricity, because it's able to be free, right? It can jump away from that atom into another atom. So if you lose electrons, it's not going to change the structure of the element. So electricity is always around us. We just don't notice it. Static electricity is when electrons sit patiently on a surface. But the best way to get electrons onto a surface is through a rubbing motion, right? So we can rub our hands, we can rub a balloon to our hair. Usually any nice woolly or rugged surface, something with a lot of friction. So by doing that, we now charge up our surface negatively, right? So if it's a balloon, right, just say it's neutral, rub it against our hair or our sweater for a good bit, and we pull it away, and that balloon is now negatively charged because it has electrons on its surface through the rubbing process. If you're at home and you have a rug, And I don't know, whatever. Maybe you woke up in the morning, you had your socks on, and maybe you're feeling a little tired, so you shuffled your feet on the rug. Right? That rubbing motion between your socks and the rug is generating uh, electrons, right? You're getting that buildup charge on your body. And the funny thing about electrons is they're on the surface. So even though you charge your feet up, the electrons could travel to your hand, which could lead to a pretty surprise when you touch a doorknob or any other metallic or conductive surface. When we think of current electricity is when those same electrons are now flowing through wire or a conductor. Some people say water, but I prefer traffic, right? If we think of the electrons as like little cars, they'll flow through.
If you'd like to learn more about the way circuits operate, click on the link below to watch the Princess Electron video.
If we have an exposed piece of wire and a conductive surface touches it, right? Let's say I had a paper clip and it touched one wire to another wire that it's not supposed to touch, it's going to create something that we call a short. And this is when the electrons get excited and they see a much easier path that they can take. So if we treat a circuit like a daily drive, right? You start at the battery, that's home, and you go to the LED, which is school, and then you come back home, right? That's your circuit. Battery, LED, home, school, right? But now if we had a new path, this short in our circuit, where we can actually take a road to skip the LED or school altogether, I think most of us would take that path. So instead of going up to the LED or school, we would take this new path, which is a short in our circuit or our daily lives, to come back home so that we can do whatever we'd like to do. There are also times when paths are now removed. So instead of a new path being created, a current path is destroyed. So let's say if we're working on our circuit between a battery and an LED, we have some wires that connect the two, and one of the wires accidentally gets cut. Now our circuit is broken. And this is what we call an open circuit. An open circuit is when the circuit is not fully rounded out. So there's a break in the path, there's nowhere for the electrons to go, so they can't go through their full daily cycle. Normally, a circuit is closed, and that's when the electrons can go about their day, right? All the paths are clear, the electrons know where they're going, so they can constantly flow through. A switch is a way that we can make our circuits open and close through manual means, right? So in your house, you might have a light switch, you might have a TV switch, right? And these switches will open and close the circuit. So if we want to turn off the lights in our house, we'll flip the switch down. It creates a break, which now makes that circuit open. So electrons can't flow through. Light goes off. Whenever we want the circuit to come back on, we want lights on in our room, maybe we want to turn on our TV, we flick the switch, we turn it on, and it closes the circuit back up. So now electrons can continue their daily flow. Electrons we can see as cars, right? Going over the paths, which are the wires, right? Roads. So if we think about more components in terms of our car analogy, a switch can be a drawbridge, right? So a drawbridge is when, it'll lift up, maybe let boats flow through, and then it'll come back down to let cars continue flowing, right? Just like a drawbridge, our switch will open, right? To tell cars or electrons, hey, stop for a moment. We want to make sure that there's no activity so we can safely allow the boat to go through or so that we can safely turn off our circuit. And then when we're ready again, we would lower the drawbridge or turn the switch on to create a closed loop and then say, okay, everything's safe, good to go, continue on flowing through the circuit.
If you'd like to do a fun experiment that has you open and close circuits, please click below for the electrons circuit video. Thanks for joining us for another episode of Pairing University. First, let's ask a couple closing questions. What are the three basic building blocks of an atom? What is the free electron? And how does that relate to the atom and electricity? Finally, what are the two different types of electricity?